Welcome to the aCassiopeiae 8800 microcomputer demo. This is a modern replica and miniaturized replica of the original Altair 8800 microcomputer. Our computer consists of a front panel, which is shown here, at least 2 cards to emulate the CPU and RAM, and then a back panel for those cards to plug in, and which provides power and a data bus. The front panel allows you to view locations in memory and then program those locations in memory with data, and then step through that memory to run an actual program on the CPU. To start our computer, you're going to want to plug in the USB-C cord at the very back. You should also open the top panel, which normally slides in. You would undo these screws, and then you're going to plug it in, and you're going to come to the front here, and you're going to flip on the on switch, and finally you're going to go to the CPU card and you're going to click reset, and this will flash a beginning program on the computer. That program can be shown here, in which there are 5 hexadecimal values at addresses 0 through 4 in memory, and these represent move I instruction and add I instruction, and then a halt instruction. So the first instruction is 3E, and that's at location 0. The second row of LEDs indicate the address, and we're at 0, and then the data indicates what data is present, and this of course shows 3E. Now to go through our PSDRs, I just demonstrated that our design for the 5 volt to 3.3 works as we are converting that power, and then I will now show the Intel 8080 process. I will now actually, what we just showed as well is the I/O expanders working, and we will actually, because those will be connected to the switches and the buttons, and let's do those 2 and 4 right now. So you can click the step button here to go through an instruction. So we just went through the first instruction, 0, 3E, and 0, 5, and now we're on the second one, which is 6C, or C6, and that's what's shown at location 2, and then we step again, and now we are at the halt instruction, which is 7.6, and we click, and now we are halted, and this is just the next place in memory. And that demonstrates that our CPU is being able to emulate, and then our I/O expanders, which are connected to the buttons and switches, also work. As for the bus, the computer would not work without the memory controller being connected to the CPU, and thus the front panel. So if we were to disconnect the memory here, and we were then able to click the step button, you can see we are unable to do that. However, when we plug it back in, and we click step, or at least reset, we're stepping through uninitialized things of memory because the memory was reset. And that's what shows our bus is completely implemented in both hardware and software.